Hi there, here's Chapter 3 notes for investigating associations between two variables. Now, up until now you've been using independent and dependent variables. Now the words we need to use are response variable and explanatory variable, so RV and EV. Easy way to really remember it is somewhere in your resource notes, just jot down that the response variable is your dependent variable, which is your y-axis, and explanatory variable is your independent variable, which is your x-axis. If you can just jot that down somewhere, maybe at the top of your book, start of your exam, jot it down on top of your exam, just that if you're not sure what the response and explanatory variables are, but you do remember which your dependent independent variables are, you can make a quick association between those. Comparing variables. When you've got a set of data, it might be in a table, and you're having a look at it, make sure you compare them as percentages, because just looking at them, the data might lie to you. It might look a lot different. For example, 2 out of 10 may look really bad, but if you're comparing 20 out of 1,000, you've got to turn those two into percentages and then have a look at which one is the better percentage. So make sure when we're comparing, you must compare them as percentages. Careful when identifying your RV and your EV variables in tables. Here's an example. These are your RV variables across here. So for example, your attitude for, against, and your EV variables are here, so male and female. Be very, very careful. Have a look in Chapter 3 for some further examples of this if you're unsure of how to identify. When comparing numerical values, we use the median as the means of centre. So make sure you've lined them all up in size order, because median needs to be size order, and then we use that as a measure of centre. Correlation coefficients, which we denote as just the small letter r, is a measure of the strength of the linear association between two variables. Before you go any further, you need to make sure you tick these 3 things: numerical, linear, and no outliers. To calculate your R, it needs to satisfy these 3 things. This will pop up in a multiple choice question. They may have a set of data and they're asking, can you calculate the correlation R coefficient? Just double check these 3 things. It must be numerical, it must be linear, and there must be no outliers. Finding out once you found out the R value, you can use page 111 to see what these coefficient values mean. So page 111 of your textbook, if something's negative, it's going down this way. If something's positive, it's going up that way. Up the top here, there's 4 scatter plots that show the correlation, the strengths, and in this table here, it tells you what those strengths are. So if you're calculating your R correlation coefficient and it falls between 0.75 and 0.99, it's a strong positive. If it falls between negative 0.75 and negative 0.99, it's a strong negative. So having this somewhere accessible in your resource booklet is very, very important. And identifying if something's negative or it's positive. Coefficient of determination. This is where we square our R value. Once we square it, we still have a decimal, but if we turn this decimal into a percentage, it tells us the degree of what one variable can predict the other variable. When you are going from your R squared back to your R, we square root our R squared value. Whenever you square root a number, the answer is either positive or negative. So it can be either positive or negative. So if you've got an R squared value and it's asking to calculate your R, square root the value, but make sure you say that it's either positive or negative. If you've got a graph there and you can see that all the data points on that graph are in a positive relationship, then you can actually say, well, this R value is positive. If there is no graph to determine whether your R is a positive or negative when you're coming from your R squared, you need to actually write it's a plus or minus R value. So this little sentence here is definitely a template you should have in your resource booklet. Once you've calculated your R squared percentage, so just timesing it by 100 or moving the decimal place twice, you can put it just in this sentence, say what your RV value is, say what your variable is, and say what your EV variable is, and this sentence is enough to explain what variation of the data is explained by the other variation of the data. This template is a must-have. So how can you calculate your R and your R squared values on your calculator? Here's the information here. However, I'll quickly show you on the calculator. We've got our X values and our Y values. Place these in, make sure that these are your X values and these are your Y values. Place them into your stats. Click Calc, Regression, Linear Reg. Check that your X values are in list 1, check that your Y values are in list 2, and click OK. Up pops all the information, so you could work out your linear rule by using the A and the B here, and here there is your R, and there's your R squared value. So to get this value, the R squared value, you can just square your R value. So very important that you know how to find that information. Then when you click out, it automatically plots the line of best fit in your data. So to summarize that, click Calc, Regression, Linear Reg. Make sure your X and Y lists are the right list, and click OK to get that information. Careful when you're putting all your information on your CAS calculator. It works very, very slow. It's got a slow memory. So if you're typing in really quickly, it actually sometimes misses numbers. So instead of maybe putting 15, you press 1, 5, enter really quickly. It might only actually recognize that you've pressed 1 and enter. And that is enough just to stuff your data up and get a wrong R or R squared value at the end. So be very, very careful. Take your time. Check the information is going in. Observations between variables is never enough just to justify the variable are causally related. You need to specify a little bit more of how these variables are related, whether you're using your R or your R squared value. So just an observation, just looking at go, yes, these are related, isn't enough to justify it. So make sure you've got more information than just an observation. And on page 125 of your textbook, this gives you which graph to use when you're using particular types of variables. So if you look at your textbook on page 125, if our RV value and our explanatory value are both categorical, we would use a segmented bar chart or a parallel bar chart. So just knowing your RV and your EV values, what type, whether they're numerical or categorical, there's specific graphs that you need to use to represent that data. Thank you for watching.